4 points on the graph of a function f of x are shown below. Which equation represents f of x? So basically in this problem we can do this graphically by plugging into our calculator each of these functions and see what they look like. We could also sketch them by hand, but we do have to be conscious of time, so the fastest way to do this problem is probably to test each of these ordered pairs in the equations below and see for which equation all of these ordered pairs would make it hold true. So let's try the very first one, f of x equals 2 to the x, and see if everything holds true for that one. So I'm going to make a table of values, x and y, and we're going to plug in for x the first number in each of the ordered pairs, and we'll see if what comes out is the second number in each of the ordered pairs, the y coordinate, and if it does, then we'll know that's the right one. So when we put in 0 from the first ordered pair, what do we get out? Well, we get out 2 to the 0. Anything to the 0 power is 1, so we put in 0 and we get out 1. That's correct. What happens when we put in 1? We get 2 to the first power, which is 2, so we put in 1 and we got out 2. So far so good. On the next one we put in 2, the x coordinate, and we get 2 squared, which is 4. Put in 2, got out 4. We're still good. Does the last one work? We put in 3, we get 2 cubed, which is 8, and yes, it did. So the answer is the first one. And you could go through with the other 3 and verify that they don't work, and you'll find at least one case, maybe more, where they don't work. For example, in the second one, if you try, if you put in 3, then you'll get 2 times 3, which is 6, and you want to get 8, so it doesn't match up. In the second one, in the third one, if you had tried here, suppose you tried 2, 4, you'd get 2 plus 1 equals 3, not 4. So we have to get rid of this one. We got rid of that one already. And here we could do a whole video on logs, and we most likely will while getting ready for the Regents, because you are responsible to know logs as well. Best bet here is probably to put it in your calculator, but your calculator can't do log base 2, it can only do log base 10. So we actually have to do what's called a base conversion. And again, we'll get into more detail on this in another example. But it would be log base 10 of x divided by log base 10 of 2. So you have to put all of this into your calculator. The only thing that you're putting in as an input from here is the x coordinate, and what comes out is your y coordinate. And we could do the same procedure and make a table of values, and you will find that this does not work. It's also helpful for this problem to have a general idea of what shapes each of these functions has. So when we're talking about an exponential function, it might look something like this. That's the general shape of 2 to the x. So that's 1. When we're talking about 2x, that's a linear function with a slope of 2. So that might look like this. So this is the second one. When we're talking about x plus 1, that's also a linear function. So it has a y asymptote of 1 and a slope of 1. So it's not quite as steep as y equals 2x. That's the third one. And a logarithmic function here, number 4, if I have any more space, has a general shape like this. And that's not perfect. You'll see it's a little different if you put it in your calculator. This is just sort of a quick sketch. You could do this with exact values. But it's good to remember the general shape of different curves, and it'll help you see if your answer makes sense for problems like these and others as well.